In chemical engineering, we often deal with mixtures, therefore it is important to understand these variables: mass fraction, mole fraction, average molecular weight, and concentration. In a mixture, the mass fraction of a certain component is defined as the mass of this substance divided by the total mass of the mixture. Xi, I indicates component I, equals to Mi, the mass of component I divided by the total mass. Therefore, if we add up the mass fraction of all the components in this mixture together, then we get 1. Because mass fraction is a ratio, it is dimensionless. Similar to mass fraction, the mole fraction of a component in a mixture is defined as the number of moles of this component divided by the total number of moles of all components in the mixture. Yi equals to Ni divided by the summation of Ni. Similarly, if we add up the mole fractions of all the components in the mixture, we get 1. And again, because mole fraction is also a ratio, it is also dimensionless. Let's look at this example problem. If we assume that air is only made up of oxygen and nitrogen, and the mole percent of oxygen is 22%, and as you know that in reality that is not the case, we need to determine that first, the percent by mass of nitrogen and oxygen, and secondly, the average molar mass of air. In this problem, we are given that the mole percent of oxygen is 22%, and that means that the mole fraction of oxygen is 0.22. And since the sum of mole fractions of all components in the mixture equals to 1, and this mixture only has 2 components, oxygen and nitrogen, therefore the mole fraction of nitrogen equals to 1 minus 0.22, which is 0.78. Now let's assume that the total number of mole for air is only 1 mole, and therefore we would have 0.22 mole oxygen and 0.78 mole of nitrogen. And we can look up the molecular weights of oxygen and nitrogen and calculate the molar mass to be 32 gram per mole for oxygen and 28.02 gram per mole for nitrogen. So from here, we can calculate the mass of oxygen to be 7.04 gram and nitrogen 21.86 gram. And therefore, the total mass of this mixture is 7.04 plus 21.86 to be 28.90 gram. So, by definition, mass fraction equals to the mass of a certain component divided by the total mass. From here, we can calculate the mass fraction for oxygen is 0.24, which is 24%, and the mass fraction of nitrogen is 0.76, which means 76%. For average molar mass, if you recall from the previous video, molar mass is defined as mass divided by the total number of mole. Here we have already calculated the total mass is 28.90 gram and the total number of mole is 1 mole. Therefore, we can easily calculate the average molar mass for air, reported with appropriate significant figures, to be 29 gram per mole. In fact, based on this example problem, we can also derive a very useful formula to determine the average molecular weight for mixture. In this formula, Yi is the mole fraction of a certain component, and Mi is the molecular weight of this same component. Oftentimes, a mixture takes the form of a solution, which is a homogeneous mixture with a solute or multiple solutes uniformly distributed in the solvent. If it's an aqueous solution, then the solvent is water, which is very commonly used. And in the solution, the amount of the solute is normally described by its concentration. Although there could exist different definitions for concentration, in this class we define mass concentration to be the mass of the solute divided by the total volume of the solution, and molar concentration to be the number of moles of the solute divided by the total volume of the solution as well. And here are their dimensions and SI units. When the molar concentration is expressed in the unit of mole per liter, it is called the molarity of the solution. For example, if we say let's make a 2 molar sodium chloride solution, this means that the solution will have a molarity of 2 and the concentration is 2 mole per liter. To describe a very small amount, trace amount of substance, we can use ppm and ppb. ppm means parts per million and ppb means parts per billion. And they are similar to a very familiar concept, percentage, which means parts per 100. And just like percentage, ppm and ppb are both ratios and therefore they are dimensionless. They could be either mass fraction or mole fraction. Let's look at this example. We have 420 gram orange juice in a bottle, and if the pesticide level in this bottle is 15.0 ppb in mass, we need to determine the total mass of pesticide inside this bottle. So in this problem, the pesticide level is given as a mass fraction 15.0 ppb, which means 15.0 parts in a billion, that is 10 to the 9th power. And that is 1.5 times 10 to the negative 8th power. And by definition, mass fraction equals to the mass of the component divided by the total mass, and we know the total mass is 420 gram. Therefore, from here we can calculate the mass of pesticide inside this bottle to be 420 gram times this mass fraction, and that is 6.3 times 10 to the negative 6th power gram, which is 6.3 microgram.